look at proof by induction using divisibility, and then we'll go through inequalities. I really like this one. I think it's pretty cool. So let's figure out in this question what we're trying to prove. So we're trying to prove that 3 to the power of 2m plus 7 is divisible by 8. So 3 to the power of 2m plus 7 is equal to 8 times some number m, where m is within z. Our first step, we check true for the smallest value of m. So what is the smallest value of m? We turn to our information right here, very useful. So n has to be an integer and it has to be greater or equal to 0. So what's the smallest number you know that is both an integer and greater or equal to 0? The answer should be 0. So everywhere I see an n, I'm going to plug in a 0, and hopefully 3 times 2, n equals 0 plus 7 is some number that's divisible by 8. So let's check. 3 to the power of 2 times 0 plus 7, well, that is equal to, anything to the power of 0 is just 1. 1 plus 7, that is equal to 8. Now 8, I'm pretty sure, is divisible by 8. Hey, this is the form 8 times 1 or 8 times m, where m is within z and m is equal to 1. So it is true for n equals 0. Okay, second step, assume true for n equals k. So everywhere you see an n, just plug in a k. So I'd get 3 to the power of 2k plus 7 equals 8. You can leave m as it is, and just remember that m is within z. 3. This one's actually a nicer step than summation. So we've got to prove true for n equals k plus 1. So everywhere you see an n, this time all you're going to do is put a k plus 1. So I would have 3 to the power of 2, put the brackets in, k plus 1 plus 7 equals 8. And I'm just going to let this be x. X is within z. So I've used a different integer here because notice 3 to the power of, say, 2, let's let k be 5, right? 3 to the power of, that would become 10 plus 7 might be 8 times, I don't know, 6. But 3 to the power of 2, if k is 5, now I have 3 to the power of 2 times 6 here, which is 3 to the power of 12 plus 7. Well, that's going to give me a bigger number or output. So it may be 8 to the power of 8 times 9 or 8 times 10 or 8 times 11. So the m and the x are probably going to be different here. Let's prove it. Now, before we prove this, I want to show you a helpful hint. Rearrange your 2 in terms of 3 to the power of 2k. So if I did that, I'd get 3 to the power of 2k equals 8m minus 7. This is what we're going to use in our step 3. You don't have to, but I find it a little bit more helpful, and you can do this for almost every divisibility problem. Okay, let's prove. We have our left-hand side and we have our right-hand side. So left-hand side, I'm just going to write it again, but this time expand the brackets. So 2k plus 2 plus 7. The right-hand side is still just 8x. We're going to prove that they're the same, or in the same form. So remember that if you had, say, x to the power of 14, you could write this as x to the power of 10 times x to the power of 4. Or x to the power of 10 plus 4. I'm going to do the same with this 3. So I can actually rewrite this 3 as 3 to the power of 2k times 3 to the power of 2 plus 7. Right? Exactly the same thing, because when we times two things together, we can just add their indices. Now I have an expression from 2 to help me, right? I can let 3 to the power of 2k equal 8m minus 7. Let's do that. Times 3 squared plus 7. Okay, that's going to become 9, 3 squared. So let's just maybe expand this. So I'll get 9, 8m minus 7 plus 7. Now you can expand this fully. I'm going to write it a little bit differently, but feel free to go ahead and expand it. This is the same thing as, 8m times 9 minus 7 times 9 plus 7 times 1. Kind of like Diophantine, we see that I'll have 8 times 9m, and then I'll have, well, minus 7 times 9 plus 7 times 1 would be minus 7 times 8. And notice here, the 8s can come out the front, so I'll get 8 9m minus 7. Now, of course, from this step, you can just expand and then try and factorize that 8 out the front. It will work the same way. And this is what I want, hey, because I have 8 times something here on my left-hand side and 8 times something here on my right-hand side. So, therefore, 8 times 9m minus 7, that is of the form 8x, right? We've just got to check that my 9m minus 7 is within z. So 9m is an integer, minus 7 is an integer, that is within z. Okay, so I've just proven the left-hand side can take the form of the right-hand side, and therefore my step 4, I'll just put it here. Obviously, your work is a lot neater than mine. We can say, by induction, this is true. Well, again, we start with n equals. Remember, we start at n equals 0, n equals 1, n equals 2, dot, 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 for all n. And we're done. So the trick here is just to rearrange in step 2 your equation. You could have rearranged it for the 7 or for the 3 to the power of 2k. It doesn't matter which, and then plug that in somewhere in your step 3.